Okay, so here we will talk about the Lewis dot structure for iodine oxide pentafluoride. And this is the Lewis dot structure. You add out the valence electrons, which gives you 48. And then you subtract 14 from the bonds, which leaves you 34 electrons. This is how it's drawn. And for our next slide, showing the Vsepr diagram for iodine oxide pentafluoride. Here you can see I drew the Vsepr diagram. All angles are 90 degrees. This is because it is an octahedral. Since they're both since all of these have bond pairs, there will be no repulsion. So that's why they're 90 degrees. You can see also that I made the orbital model, and based on this you can also see the 90-degree angles here for all of them. You can see it in 3 dimension. And here as well, you can see the double bond here with oxygen. And you can see all the fluorines down here. And these will also be 90 degrees, as you can see. And this will be it for the Vsepr diagram. Next I will do another molecule, which is going to be the hydronium ion. Okay, here is our Lewis dot structure for hydronium. Here we have 6 valence electrons from oxygen, and we have 3 valence electrons from hydrogen, which will give us 9. And you subtract 1 because you have another, you're getting rid of an electron here. So you will be given 8 electrons altogether. So now you have 2 here, 2 electrons. You have another 2 here, and another 2 here. So you have 6 in bonds, and then you have another 2 up top. And then you bracket the whole thing, and then you add the positive, because that's the ion. And that is it for our Lewis dot structure for hydronium. Next is our Vsepr diagram for hydronium. You can see, based on our previous Lewis structure, that there was a lone pair up top. And since there is a lone pair at the top, you have a lone pair to bonding pair is greater than bonding pair to bonding pair. So this lone pair is repulsing the hydrogen. So it's pushing the whole thing downward, which will give the angle only 107.3 degrees. And you can also see on this diagram, and as well as this one that I made, that the lone pair is up here at the top still, and it's still kind of pushing these down. So that is it for our Vsepr diagram for hydronium. Thank you for listening, and have a good day.